Welcome to Session 13, Functions, Notation, and Inverses. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to evaluate function notation, to reverse a function to find its inverse, and to verify inverse composition. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. A function maps inputs to outputs, and inverse reverses that map. Use this visual structure. Int is greater than rule, is greater than opfit, inverse, opfit, is greater than rule backward, is greater than ont. Read every symbol and label before calculating. The first goal is to evaluate function notation. Connected to the second goal, reverse a function to find its inverse. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Identify input, rule, and output. State the target and preserve its units or conditions. Step 2. Replace the input everywhere. Use a separate line so signs, factors, and labels remain visible. Step 3. For an inverse, swap x and y and solve. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Compose the two rules to verify. Verification is part of the solution because it tests the answer from another direction. Signal 1 is f of a number. Respond by remembering. Substitute the input. Name the response before calculating. Signal 2 is inverse requested. In that case, reverse input and output. The form tells you which tool fits. Signal 3 is a table repeats an input. Remember, check the function condition. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Which test determines whether a function's inverse relation is also a function? Restate what is requested before touching the choices. The first move is identify input, rule, and output. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. A horizontal line checks whether an output comes from multiple inputs. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. For an inverse, swap x and y and solve. The explanation supports one option without relying on its position. The mathematical conclusion is horizontal minus line testament. State it with any required units, in interval notation, or restrictions. The final answer is horizontal minus line testament. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Show that both compositions return the starting value. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. A function converts Celsius to Fahrenheit. What does its inverse do? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. Focused hint. An inverse reverses the original input minus output process. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is converts Fahrenheit to Celsius. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to evaluate function notation. Combine that with the discipline to reverse a function to find its inverse. Finish by remembering to verify inverse composition. A result becomes dependable only when the method and verification are both clear. Reflection. Which operation must be undone first when reversing the rule? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.